In this part, we will discuss a little bit about precision and the theory behind it. When we think about obtaining results from our sample, we can analyze subsamples and we can do it multiple of times. For example, we can do 8 different analysis results. And these results are never exactly the same. It means that there is a random effect affecting these results. And this is characterized with a validation parameter called precision. We can estimate precision with differently. The first thing is when we analyze, for example, our glyphosate groundwater in one day, we would do subsamples and analyze them 4 times. This means that we would have one analyst, our calibration graph is the same, we would have the same eluents, chromatographic columns. And this precision is called repeatability. The second way is to analyze those subsamples on different days. It means that we would start to vary different parameters. Maybe we would have a different analyst, maybe we would have changed the chromatographic column. We definitely would have other reference standards. And this precision is called intermediate precision. This intermediate precision is oftentimes confused with reproducibility. Reproducibility is mostly used and correctly used when we would analyze our samples in different laboratories, for example, laboratory 1 and laboratory 2. And when we estimate and compare these results to each other, we would actually get an estimation of reproducibility. When you're doing a single laboratory validation, it's not the parameter you should really worry about. However, when your method is validated for multiple of laboratories at the same time, in that case, you should really consider analyzing reproducibility as well. So the question becomes, how do we express precision? What kind of mathematical calculations to use? The correct way would be to estimate standard deviation, and we can use this formula for absolute standard deviation. The problem with this formula is that we would get an absolute standard deviation, and this means that when you would like to compare your precisions that are obtained for different sample concentrations, it would not give you a very good overview. For that reason, it is recommended to use relative standard deviation. When you think about the standard deviations that you have obtained, there's a general rule to follow, and it is that the standard deviation of a repeatability should be smaller than intermediate precision standard deviation. And if this is not the result, it means that there's some small flaws in your validation procedure. Maybe you don't have enough replicates for your repeatability, or there is a too short time interval for your intermediate precision. So these are important things to keep in mind. And in the practical part of the precision, we'll give more practical information how to calculate precision. So this was the small introduction to the theory of precision.